Hello, welcome to 1.8, rational and radical functions, or equations. Okay. Simplifying rational expressions. A rational expression, think of it as ratio, rational expression, an expression that can be written as a ratio of two polynomials, p over q. So basically a fraction. So rational number, ratio of two numbers, fraction. Simplified or reduced form, when p and q have no common factors other than 1, we should say a and b in this case. AC over BC equals A over B. A couple typos in that one. So when A and B have no common factors other than 1 or negative 1, AC over BC, the C's divide out, you get A over B. So the first one, it says, example 1 says, simplify the following rational expressions indicating which values of the variable must be excluded. Now what must be excluded? You must exclude values that make the denominator 0. What do we have here? That's going to be x plus 6 times x minus 1, looks like. Down below, I could pull an x out, and we'd have x squared plus 2x minus 3. That's going to be x times x plus 3 times x minus 1. So right off we see that x cannot be 0 from that. X cannot be negative 3 because I make that 0. And x cannot be 1 because I make that 0. So the x minus 1's divide out, and we're left with x plus 6 over x times x plus 3. Okay, for the next one, in the numerator I can factor out an x cubed, and we're left with an x minus 1. Down below we have x squared minus 3x plus 2. That's going to factor be x minus 2 times x minus 1. So right off we see from down below in the denominator x cannot be 2 and x cannot be 1. Because if you put 2 in here you're going to get 0. If you put 1 in there you're going to get 0. And we can't have 0 in the denominator. X minus 1's divide out. So we get x cubed over x minus 2. Okay. Let's go on to the next page. So this was simplifying rational expressions. Now we're going to do some combining. That means adding, that's the first thing, adding, subtracting fractions, and then multiplying and dividing fractions. So, to combine two rational expressions with addition and subtraction, the rational expressions must have a common denominator. So once you get to a common denominator, we'll call it C, A plus or minus B, A over C plus or minus B over C, it's just going to be A plus or minus B over C. To combine two rational expressions with multiplication, this is a lot easier. Multiply the numerators and multiply the denominators and simplify when you can. A over B times C over D is AC over BD. And to combine two rational expressions with division, multiply the left expression by the reciprocal of the right expression. So A over B divided by C over D is A over B times the reciprocal of C over D, that's D over C, which would be AD over BC. Let's look at example 2. Add or subtract the rational expressions as indicated. So we have to get common denominators first. We have x plus 1 over x minus 3 plus, then we have x squared. I think I'm going to factor this numerator to be x plus 2 times x plus 1 over, and the denominator will factor to be x minus 6 times, nope, x minus 3 times x plus 2. That'll work. And then minus x squared minus 2x minus 3 is x minus 3 times x plus 1 And this will be x minus 3 times x minus 3. So the nice thing in here, when you factor that down, it's going to, some things are going to divide out, like the x plus 2's, x minus 3's. So we're left with x plus 1 over x minus 3 plus x plus 1 over x minus 3 minus x plus 1 over x minus 3. Well, look at that. X plus 1 plus x plus 1 minus x plus 1. That's just going to leave an x plus 1 over x minus 3. So these two are just going to subtract out. I'm going to go on to the next page, so pause it if you want some more time. The next one says to multiply or divide the rational expressions as indicated and simplify your answer. So let's factor each part first. So this is going to be 3x, x, multiplies to be 10, adds to be negative 1. Means if we did a minus 2 and a plus 5, we should have, because 3x times negative 2 is negative 6x, 5 times x is positive 5x, it'll give us negative x. 5 times negative 2 is negative 10, and 3x times x is 3x squared. This x squared minus 1 is x minus 1 times x plus 1. 6x squared plus x minus 15, that's going to be what? I bet that's another 3x and a 2x there. Now let's see, if I do 15 factors to be 3 and 5, what if I did plus 3, I'm going to have to do minus 3. Minus 3 and plus 5. Why that? One's negative, one's positive because of the negative 15. 3x times negative 3 is negative 9x. 5 times 2x is positive 10x. We get an x out of that. And then we'll be doing dividing by x minus 2 times x plus 1 over 2x squared plus 5x minus 12 factors to be 2x. And then we'll have an x. Got to work through this one. Negative 12. Let's see. I could do, so the middle stuff is 5x. What if we did, I wonder if we should go 6 and 2? Or should we go 3 and 4? How about that? Because 2 times 4 is 8. And then x times negative 3. So negative 3x from that, 2x plus times 4x is 2x times 4 is 8x. That'll give us 5x. There we go. So this is 3x plus 5 times x minus 2 over x minus 1 times x minus 1 times x plus 1 over 3x plus 5 times 2x minus 3 times, now we're going to flip this one because we're dividing by this fraction, 2x minus 3 times x plus 4 over x minus 2 times x plus 1. What divides out? 3x plus 5. This is the fun part. X minus 2, x minus 1, x plus 1. Ooh, 2x minus 3, and what's left? Just x plus 4. Okay, so there's example 3. I'm going to move on to simplifying complex rational expressions. Now these are complex fractions. That means a fraction, the numerator, or a fraction, the denominator, or numerator, denominator, or it could be in both. So, complex rational expressions, a fraction in which the numerator or denominator or both contains at least one rational expression. To simplify a rational expression, you can do one of the two following things. One is to multiply the numerator and denominator individually, and then, or simplify them individually, and then divide the numerator by the denominator, or multiply the numerator and denominator by the LCD of all the fractions that make up the complex rational expression. I like method 2. So we have xy, xy. The LCD is going to be xy. So we'll have xy times 1 over x minus 1 over y times xy over xy times 1 over x plus 1 over y times xy. And then some stuff's going to disappear. Not disappear, but divide out. And we're left with y times 1 is y minus 1 times x is x over y times 1 is y plus 1 times x is x. That's it. I'm going to go on to the next one. We have x to the negative 2 minus y to the negative 2 over y minus x. Let's rewrite this. That's 1 over x squared minus 1 over y squared over y minus x. So our LCD is going to be x squared y squared, because here x squared y squared, that would work for all. And this one's really just y over 1 and x over 1. So we'll do x squared y squared times 1 over x squared minus 1 over y squared times x squared y squared over x squared y squared times y minus x times x squared y squared. The x squareds divide out, y squareds divide out. We have y squared minus x squared on top. Down below we have an x squared y squared times y minus x. If I factor that out. So what's cool about this, we can factor the numerator, y minus x times y plus x, divided by x squared y squared times y minus x. And this divides. And we're left with y plus x over x squared y squared. And that's the end of that problem. So the key to this is to write these each as fractions in the numerator. Okay, that should do it for the rational part. We're going to go on to radical equations. Solving rational equations. We did the expressions doing equations. So a rational equation is an equation that contains at least one rational expression, so at least one fraction, while any other non-rational expressions are polynomials. To solve, multiply each term by the least common denominator, the LCD. You're going to clear out the fractions. Be sure to check that any solutions you get work in the original equation, because when we multiply it through by the LCD, we don't want to introduce an extraneous solution. So we have to make sure that the values we get are not going to make the denominator, the LCD, 0. Okay, so going on to the next page. Solve the following rational equation. X over x minus 1 plus 2 over x minus 3 is negative 2 over x squared minus 4x plus 3. So x over x minus 1 plus 2 over x minus 3 is going to be negative of 2 over. Now this factors to be just x minus 1 times x minus 3. So I'm going to multiply through the LCD here. Is x minus 1 times x minus 3. So what we do know is that x cannot be 1 or 3. That makes the denominator 0. We'll do x minus 1 times x minus 3 times x over x minus 1 plus x minus 1 times x minus 3 times 2 over x minus 3 equals negative 2 over x minus 1 times x minus 3 times x minus 1 times x minus 3. So I'm multiplying everything. Every term gets multiplied by this least common denominator. Every term. This divides out. X minus 3's divide out. Both of these will divide out. So we have x minus 3 times x is x squared minus 3x, plus x minus 1 times 2 is 2x minus 2, equals negative 2. So I'm going to add 2 to both sides. This is x squared minus x equals 0. X times x minus 1 is 0. X equals 0. X minus 1 is 0. So x equals 1. Oh, but wait. We can't use the 1. We have to exclude it because it made this denominator and this denominator 0. So the only solution is x equals 0. This is our only solution. Feel free to pause that one. I'm going to go on to work rate problems. Okay, in work rate problems there'll be 2 or more, typically 2 or more workers acting together, and workers I put in quotes because it could be 2 machines, could be 2 water faucets, acting together to complete a job. The workers could be people, machines, pipes filling or draining a tank. Each worker is capable of doing the task alone, but each worker works at its own individual rate regardless of whether others are involved. There are 2 keys to solving a work rate problem. First, the rate of work is the reciprocal of the time needed to complete the task, and rates of work are additive. So we have the rate times the time to do it is 1 job completes. And the rate is 1 over, I'll put little t, the time it takes 1 person to do the job. The rate of 1 person or thing. Okay, example 6 says the hot water tap can fill a sink in 4 minutes. If the cold water tap is turned on as well, the sink fills in 1 minute. How long will it take for the cold water tap to fill the sink alone? So, rate for the hot water. Think to yourself, how much of the sink is filled in 1 minute? And that's a quarter of the sink. So it'll do a quarter of the job in 1 minute because it takes 4 minutes for the whole thing. For cold water, it's going to be 1 over x. We don't know how long it takes. So we have the rate times time equals 1. Our rate is going to be 1 over 4 plus 1 over x times 1 minute equals 1 job complete. So what this is really saying is 1/4 plus 1 over x equals 1. The LCD is going to be 4x. So 4x times 1 over 4 plus 4x times 1 over x equals 4x times 1. So our 4's divide out, the x's divide out. X plus 4 equals 4x. Subtract the x. So 4 equals 3x, and x equals 4/3 of a minute. So the cold water can fill it in 4/3 of a minute. Or a minute 20 seconds. I keep doing that backwards. I'm going to go on to example 7 here. Feel free to pause that. In order to flush deposits from a radiator, a drain that can empty the entire radiator in 45 minutes is left open. At the same time, it is being filled at a rate that would fill it in 30 minutes. How long does it take for the radiator to fill? So the fill part is working at a rate of 1/30th of the radiator per minute, and the drain part is working at a rate of, now it's draining, so it's not filling, it's going to fill it at a negative rate, -1/45. It'll empty the whole thing in 45 minutes. In 1 minute, it empties 1/45. So again, our rate times time is 1. So we have 1/30 plus -1/45 times 1, or times time equals 1. This is our rate. So let's combine these. That's going to be 45/45 times 1/30 minus 30/30 times 1/45 times time equals 1. That's 45/45 times 30 minus 30/45 times 30 times time equals 1. (45 minus 30 is 15/45 times 30 times time equals 1. So the 15 and pick which one, I don't care, it doesn't matter. 15 and 30 reduce. So it's 1/45 times 2 is 90 times t equals 1. So t must be 90 minutes. Multiplied by the reciprocal. That was fun. See if I can find with a blue pen, because they're more to my color. That's going to dry. May have to finish this one with black pens. Okay, moving on to radical equations. Feel free to pause if you need more time with this. Radical equation is an equation that has at least one radical expression containing a variable, while any non-radical expressions are polynomial terms. Method of solving this: begin by isolating the radical expression on one side of the equation. Sometimes you'll have more than one, so if there's more than one radical expression, choose one to isolate and then proceed. Raise both sides of the equation by the power necessary to undo the isolated radical. For example, if the radical is an nth root, raise both sides to the nth power. If it's a square root, you square both sides. If it's a cube root, you cube both sides. Fourth root, you raise both sides to the fourth power. If any radical expressions remain, simplify the equation if possible, and then repeat steps 1 and 2 until the result is a polynomial equation. When a polynomial equation has been obtained, solve the equation using polynomial methods. Check your solutions in the original equation. Any extraneous solutions must be discarded. And you do end up with extraneous solutions in this. It's pretty common. Okay, let's run our last page actually for this section. we have the square root of x plus 1 plus 10 equals x minus 1. So if I subtract the 10, we would have the square root, stick with the black pen. Square root of x plus 1 equals x minus 11. So we have the square root of x plus 1 equals x minus 11. We're going to square both sides because that'll undo the square root. X plus 1 equals x squared minus 22x plus 121. Now we'll subtract the x from both sides and the 1. So 0 equals x squared minus 23x minus or plus 120. So 0 equals, let's see, x minus, thinking factors of 120 would be 4 and 30. It's not going to work. Both negative. 3 and 40. That's not going to work. Let's see. How about 15 and 8? So we'd have x minus 15 equals 0. X equals 15. X minus 8 equals 0. X equals 8. Now we're going to check the solutions. Check. X equals 15. So the square root of 15 plus 1 plus 10, is that equal to 15 minus 1? That's the square root of 16 plus 10, is that equal to 14? 4 plus 10, is that 14? Yes, it is. How about for x equals 8? Is the square root of 8 plus 1 plus 10 equal to 8 minus 1? Is the square root of 9 plus 10 equal to 7? Is 3 plus 10 equal to 7? The answer is no. So the only solution is x equals 15. This one is extraneous. That is why it's important to check these. Okay, I'm going to go on to the next example, so feel free to pause if you need to. Here we have the square root of 3y plus 4 plus 5y plus 6. Square root of 5y plus 6 equals 2. We want to isolate one of the radicals. So I'm going to subtract the square root of 5y plus 6 from both sides. And we'll have the square root of 3y plus 4 equals 2 minus the square root of 5y plus 6. Now when I square this, it's important to recall this. If you have a plus b, let me go a minus b for this particular problem, squared, that's a squared minus 2ab plus b squared. You can't forget the middle stuff. And that's a very common thing for students to forget in this part, is they forget the middle stuff. You know, it's extra work. Why do I want to do the extra work? Because you want to get it right. So don't forget the middle stuff. So if we square both sides, you would have 3y plus 4 equals 4 minus 2 times a is 2, so it's 4 times the square root of 5y plus 6 plus 5y plus 6, that's our b squared. Let's see, I'll subtract 5y, I'll subtract the 6, and I'll subtract the 4. We're going to have negative 2y minus 6 equals negative 4 times the square root of 5y plus 6. Now we can divide both sides by 2, negative 2. And we'd have y plus 3 equals the square root of 2 times the square root of 5y plus 6. Now I'm going to square both sides. This will give me y squared plus 6y plus 9 equals 4 times 5y plus 6. So y squared plus 6y plus 9 equals 20y plus 24. So we'll subtract 20y from both sides, and we'll subtract 24 from both sides. So y squared minus 14y minus 15 equals 0. That would factor to be y minus 15 times y plus 1. Okay, so those are our solutions. Let's check these solutions to see if they work. Let's try x equals 15 first, or y equals 15. We have the square root of 3 times 15 plus 4 plus the square root of 5 times 15 plus 6 equals 2. 3 times 15 is 45 plus 4 is 49, so the square root of 49 plus 5 times 15 is 75 plus 6 is 81. Is 7 plus 9 equal to 2? The answer is no. So that's not a solution. Now let's try the other one. Y equals negative 1. Is 3 times negative 1 plus 4 plus 5 times negative 1 plus 6 equal to 2. That's the square root of negative 3 plus 4 plus the square root of negative 5 plus 6 equals 2. That's 1 square root of 1 plus square root of 1 equals 2. 1 plus 1 is 2. That works. So the y equals 1 is the only solution. Let's go on to our last one then. Feel free to pause if you need it. Probably do this without scrolling. We have 2x minus 5 to the 1/4 power equals x minus 1 to the 1/4 power. They're both to the 1/4 power, so what if we raise them both to the 4th power? Or we could just equate the stuff inside. We would have 2x minus 5 equals x minus 1. X equals 4, excuse me. I was going to say 6, but it's 4. Let's check that. 2 times 4 minus 5 to the 1/4. Is that going to be equal to 4 minus 1 to the 1/4? 2 times 4 is 8. 8 minus 5 is 3 to the 1/4. And that's 3 to the 1/4. So it works. X equals 4. Okay, that'll do it for 1.8. This will also do it for Chapter 1. So yay, we finished the chapter. Okay. Hope you enjoyed this. Now it's a lot of work. We're reviewing a lot of material here from Math 096, mostly. So send me your questions, and I look forward to seeing you guys online. Thanks.